Hi guys, in this video we're going to take a look at computation of scalar triple product and then finding the volume of a parallelepiped that can be formed by these three vectors, and also figuring out if the vectors u, v, and w are coplanar. So what that means is, do they lie in the same plane? So first, how do we compute scalar triple product? So notation wise, this looks like this. This is going to be u, and then we dot it with the cross product of V and W. And what we get is called scalar triple product. Now, the way we compute it is by computing a determinant, and we should keep the order the way that it is. So the first row will be the first vector, the second row is the second vector, and the last row is vector number 3, which is W. Now, this is computed by, let's say, expansion over the first row. So we look at the first element right here, and then we cross out the row and the column where that element belongs to. And so we take that element, number 1, and we're going to multiply that by the corresponding determinant. So this would be 1 times -1, subtract 3 times 0. Then we move on to the next element. So that would be this one right here. We're going to take it with a negative because this element, the second one always is taken with a minus. And then multiply that by a determinant that's obtained by crossing out the row and the column where that number is. So that would be -2 multiplied by -1, subtract 3 times 1. And then finally, we take the last element. So we take this one right here. We cross out the row and the column where this guy is, and it's usually a mess by the time we get to this one. So this will be +2, and so we get the -2 times 0, subtract 1 times 1. So let's see if we can simplify that. So this right here would be -1, so this is just -1. So this is +2 minus 3, that's -1. And I got multiply that by -1, that's +1, but then we have a minus. So that's another -1. And then this is just going to be -1 times 2. So that's -2. So looks like the scalar triple product is equal -4. So from the word scalar triple product, you can hear the word scalar, right? And scalar is a number. So remember that scalar triple product is just a number. There are no IJKs, no components. This is just a number, and could be a positive number, negative number, 0, whatever. The next question says, find the volume of the parallelepiped that can be formed by these vectors u, v, and w. So I'm not going to try to draw the parallelepiped, but what we know is that the volume of the parallelepiped is obtained by taking the scalar triple product, and by the way, in any order we want, because once we find it, we are going to take the absolute value of the answer. So absolute value, why? Because the volume of anything cannot be negative. So that's why this is going to be absolute value of -4. So if you put the vectors in wrong order, or not wrong necessarily, but in any order, the difference will be that this could be +4, because when you switch rows, the sign of the determinant changes. And so, but when you take absolute value, will make no difference. So either way, the volume of the parallelepiped will just be 4. And now to answer the last question, which is asking, what about the vectors? Are they coplanar? So coplanar vectors means that 3 vectors, just imagine that you have 3 vectors, maybe this vector and that vector, and maybe you got another vector or whatever, but they all lie in the same plane, okay? If that happens, they're called coplanar. So if the vectors are all 3 in the same plane, then you cannot form a parallelepiped out of them, because the third vector will be in the same plane as the first 2, so the volume of the parallelepiped is just going to be 0. So coplanar just means that the scalar triple product is 0. So if scalar triple product u dot with v cross w, is that 0? If yes, then coplanar. If not, then no. Well, because we've got 4, which is obviously not 0, so we will say no, not coplanar.